know what you're doing. What was what? Oh, I normally record a first period. Yeah. So you're just realizing that? But I usually record first period. All right. It says, when a line is drawn parallel to the side of a triangle and intersects the other two sides. So what that's, if I show you, kind of walk you through this here, what those words are saying. Here's our triangle. If I then draw in a line that's parallel to one of the sides, so notice how this line got drawn in. These little arrows tell you that it is parallel to this third side. And then it intersects the other two sides. When that happens, we are guaranteed to have similar triangles get formed. Okay? And it's similar to what we just talked about with the one that Maya had asked about. These are corresponding angles right here. This angle corresponds to this angle. So the small triangle's lower left-hand base and the big triangle's lower left-hand base have to be congruent. This is a corresponding angle to this guy. So those are congruent. And then this angle is actually shared by both of them. So through the idea of angle, we can definitely know that these are going to be similar triangles. Okay. All right. It says, for example, give the similarity statement of this over here to the right-hand side. So the first thing we're going to do is, based upon what we just talked about, let's write a similarity statement for the two triangles that we see. So the first one I'm going to write is the smaller triangle that's kind of inscribed inside of the bigger one. So we're going to say that triangle, and I'm going to start with this top part, the A. So A, B, E. So I went from A down the left-hand side across the bottom is going to be similar to triangle. And then just to kind of make sure we understand how these are similar, one's inside of the other, we'd have to start at what angle for that second one? A. And that is also why, if that one is shared between them, we have one angle that's congruent no matter what, one set of angles. And then we have to go down the left-hand side to C. C is the big left-hand side. And then across the bottom of the big one, which is D. Those are our similar triangles. So angle A and A obviously are the same angle, so they're corresponding. B and C correspond, so that's this angle here, and then E and D correspond. All right, if I ask you to find the scale factor, if we look down the left-hand side of the small one, we don't know that, so we don't want to be using the left-hand side of the small one for that. If we look at the bottom of the small one, we don't know that. The only complete set that we know is the right-hand side of the small one, which is 5. So we need to compare that to the right-hand side of the big one. All right, what is the right-hand side of the big triangle? 8. How'd you get that? Good. So the original 5 got us what we already would have had, but then we get this additional 3 right here. So we can write this as 5 to 8. I'm not telling you to go from one to the other. So 5 to 8 or 8 to 5, either one of those options we would be okay with right now, since we weren't specific. All right. Once we have that, though, we talked about how we don't know X, we don't know Y. That's what we're going to do now to solve this. So it's a set up a proportion to solve for X. So if I now wanted to solve for X here, I definitely need to use this X for one of my sides. And I'm going to use the ratio that I already knew from the previous problem. So I'm going to start with this 5 over 8, the right-hand side of the small one over the right-hand side of the big one. I'm going to set that equal to X is the left-hand side of the small one. So understand what I did. I put the small one on top. I put the big one on the bottom. So when I come over here, the X must go on top. And then what we need to put right here is the left-hand side of the big triangle. So write down what you think the left-hand side of the big triangle would be. And you're going to put it right there. All right. Anybody know how we need to write that? What we write here? What is it? All right. We agree with that?
I didn't do it that way.
You didn't do it that way? How'd you do it?
I did 2x plus 8.
Okay, let's get to the 2x part. So when we come up here, notice how I wrote this. Didn't I take the 5 when we wanted this big side? Don't we just increase it by whatever this number is? So let's do this. Let's say x ended up being 10. So don't write this down because we don't know what it is. If this was 10, how big is the left-hand side overall? 12, right? Let's say this was a 7. How big is the left-hand side? 9. What are we doing? Are we adding these together or are we multiplying those together? We're adding them, right? So instead of doing 2 times x, so 2x means we're multiplying them together, we just want to add those together, and you're going to write that as an x increased by 2. Okay? We can't actually put them together because they're not like terms. So you're just going to write that as a sum, the x increased by whatever that 2 is going to be. Okay? Once we have that, this is one of the ones that I put on your quiz. So we just took the quiz. You got that back yesterday. If you did corrections, this was one of the ones on the last page here where we're going to cross multiply. So the 8 and the x is easy. You're just going to get the 8 times x. But then here, just be careful. This is now a binomial. We have 2 different terms. So we need to make sure that that 5 is going to get distributed to both the x and that 2. When we do that, 5 times x is 5x, and then 5 times 2 is going to be a 10. And then that would equal the 8x on the other side. All right, and then just continue solving that. We're all pretty good at solving little equations like this, so we would all be good from here. Subtract your 5x over. Oops, there's no x there. Divide by 3. You can give me the fraction. This is not a good number in the sense it's a whole number. So 10/3 is fine. Or if you want to write that as 3.3 repeating, all right, that decimal is also fine. Okay. Really common idea here that you're going to see in this chapter is this whole idea that we're going to have the unknown side and it's going to get increased a little bit. And we just want to write that as a sum. Okay. All right. Last one. Set up a proportion to find y. So again, I'm going to use this 5/8 that I found at the very beginning. So I'm going to put that 5/8. It's the right-hand side. So I did the small right-hand side over the big right-hand side. If we now look at where y is at, the y is the bottom of the small one. So I'm going to take the bottom of the small one and I want to compare it to the bottom of the big one. And we have to do the small one on top and the big one on the bottom. So the y is the small one. The 10 is the big one. That one everybody can do, right? You just cross multiply and then solve. So you're going to do 50 is equal to 8y. Divide, is that 6.25? Somebody check me on that, pretty sure. Is it? Yeah. All right, and then y should give us 6.25. Okay. So we're going to do this fairly often. This is little triangles inside of a triangle. So we want to understand how we can kind of handle that. All right. Now, the next thing is what is called the side splitter theorem. And the side splitter theorem, as you can kind of read here, says that it gives us a shortcut. Shortcuts generally are good. Shortcuts to finding the sides of the split sides in the triangle that we just did above. All right. So here's what we want to get out of this. It says if a line is drawn parallel to the side of a triangle and intersects the other 2 sides. So same thing that we talked about in that first problem. So here's that parallel line. It obviously intersects the other 2 sides. All right. When that is the case, we can use what is called the side splitter theorem. So here's our sides that we're intersecting, and this line is obviously splitting that up to some degree. It says if a line is drawn parallel to the side of the triangle intersecting the other 2 sides, then it intersects those sides proportionally. All right, and then we'll talk here in a minute what that means and how that allows us to do a little bit of a shortcut. All right, what I want you to do with this problem, so we can kind of understand what this means and how it's related to number 1, but this option now gives us a little bit of a shortcut. Underneath where it says finding x and y, what I want you to do here is write down this little phrase. Put option number 1. Option number one is what we did in the problem above. If I told you to solve for x right now, all right, so if I wanted to figure out what this x is going to be, then what we could do is take this left-hand side of the small one, we know that's 4, and compare it to the left-hand side of the big one. What is the left-hand side of the big triangle going to be? 5. 4 plus 1. So the left-hand side of the big one is going to be a 5. So we have 4 over 5. Notice where x is at. It's the right-hand side. So again, since I did the smaller over the larger, the smaller right-hand side is 6. So that's got to be your numerator. And then once again now, since we weren't real sure the first time, how do we write the big right-hand side? Whatever you think that is, that's what we're putting right here. Okay, so now, Hannah, how did you write the right-hand side of the big triangle? Good. It's that 6 increased by whatever the length of x is going to be. All right, so the exact same thing we did in the previous problem. Once that's set up, are we good with where that comes from? Right, understanding that. You're going to cross multiply then. So you're going to do 4 times that 6 plus x equals 5 times 6, which is a 30. We're all good at equations. You're just now going to work your way through this equation, do a little distributing. I don't want to do that just yet. Subtract that 4 over, or I'm sorry, the 24 over. So minus 24. And again, don't freak out when you don't get these really nice numbers. 4x will equal 6. When you do 6 divided by 4, that as a decimal will give you 1.5. All right. So exact same thing we did in problem number 1. What I then want you to do, draw a line in here, and we're going to write option 2. And then this is now using the little theorem that we just said, the side splitter theorem. And then we'll talk about what this means. Because the side splitter theorem, if you focus on the word shortcuts, should be a little quicker method to solve what we just solved over here. Okay? So the side splitter theorem says if the line is drawn parallel to the side, so that's that blue line, is parallel to this base, it intersects the other two sides proportionally. So what that simply means is that this length here compared to this length is proportional to this length compared to this length. So all we really need to do is take 4 over 1. So I basically just do 4 over 1. And then that would mean it would have to be what on the other side? What over what? 6 over x. When we solve this now, we just crisscross 4x equals 6. Didn't we get the 4x equals 6 later on in the problem that we just did? And when we divide that, won't that give us the 1.5 that we got doing it the other way? Okay. So that's why the side splitter theorem is called a shortcut. We can do that a little bit quicker. However, you don't necessarily have to write this part down. There is another way we can do this in terms of the proportion. I like doing it that way. I like doing the 4 over 1, 6 over x, because it's kind of a fraction anyway of whatever's on top over whatever's on the bottom. But this would also work. I could do 4 compared to 6, so left to right, and then go to the bottom ones and do left to right as well and do 1 compared to x. That would also work. Because if you notice, we still crisscross. You're still going to get that 4x equals a 6, and you're obviously going to get the same answer. Okay? Now, that's just for the sides. So just kind of understand, those are the two sides that are getting split. When we go to solve y, there is no shortcut for y. It'd be the same thing that we did above. So the y is the base of the big triangle. So we want to find its corresponding side in the small triangle. That's the 9. So I'm going to do 9 over y. So again, I did the smaller over the larger. So then I go to the other triangle. I'm going to pick the small left-hand side and compare it to the big left-hand side, which is that 5. And then that's our proportion. All right. And then these are super easy. Cross multiply. Divide. And that should give you 11.25. Okay, so that's our proportions for those. Okay, so now with that, let's go to letter A. Here is the side that's parallel that splits the other two sides. So we can use the side splitter theorem very, very quickly. I'm going to do it as this 3 compared to that 5. And if I did 3 to 5, that means the other one has to be what over what? If we understand that order. What is it? Good. 4 over y. All right, I did this guy to this guy. So then I'm going to, so small to big, and then 4 to y. If we solve that, you're going to cross multiply. So you're going to get 3y equals 20. Divide, and you'll get 20 thirds, which is 6.6 repeating. Now, first period, and we'll see in a minute how you guys want to set these up, how you see it better. We talked about in first period, and this one I did 3 to 5 equals 4 over y. I also could have done 3 to 4, so I could have gone top to bottom, as long as in the other one I go top to bottom as well. So that also would work. It kind of just depends on which way you see better. If you notice, this is still going to be 3y. This is still going to equal 20. It's the same exact equation we got doing it the other way as well. Okay. Now, the x's, no way around that one, or I'm sorry, the y here. So we know x is that 6.6 repeating. So this is now the third time I've had you do this. Find y. I'm sorry, find x. Wait, I'm screwing up. Y is 6.6 repeating. Used to solving for x first. Solve for that x there. A little trickier. We've done it twice now, though. So the third try here to see if we can do it on our own. But it's a little trickier, this one. This is one that people tend to miss. Okay, anybody confident in the proportion they have set up? Because there's a lot of different options here again. And you may see it a little bit differently than somebody else. Maria, where are you at?
30 over 8 equals x over 3.
Okay, so Maria did, she understood this is the small triangle. So she took the top side of the small triangle, the 3, and then she compared it to the top side of the big triangle, which is 8. So she did small to big, all right? Top of the small one compared to the top of the big one. So if she did 3 to 8, we have to include this x now. What would you do for this one?
X over 3.
Good. The left-hand side of the small one over the left-hand side of the big one. Okay? So good. Crisscross. We get 24 is equal to 8x. Divide by your 8 there, and then we should get x to equal a 3. Okay. Okay, letter B. Give you a minute. Solve both of those. Find x, find y, as we've now done a number of these, and see where we're at. And I want to find people who set them up a little differently, just so we can see that. So you did 7 over 3. What you can do then your issue is going to be if you want to find that y, you did the right hand. So let's do y first. Let's set up your y first. You did the big bottom over the small bottom. So that's your puzzle. So you have big bottom over the small bottom. This one always maybe any way you want. So that over that. So now you need to do a big right hand side over the smaller right hand side. So if this is the big triangle, how long is the big triangle right hand side? And how long is the small triangle? Here's the small triangle. Right. So you gotta add this up that way. Okay.
Okay, so if you're going to start with this bottom part, you have to start with the bottom part, right?
When I asked where
You can set it up using the side splitter.
Yeah. No. This one.
That way.
So you're not? Okay. When I call you, raise your hand also.
Honestly, use the side splitter. It's easier.
Okay.
Because then you just go this or that equals this or that.
Yeah.
I'll do it that way. So, yeah.
Yeah, you're gonna raise your hand. Okay, letter B. In terms of setting up letter B, I think I remember my three people. Heilman, how did you set up to find X?
I did 3 over 10.
Okay, so this is our side splitter theorem. So she did 3 over 10. And if she does 3 over 10, then she is committed to doing what over on the right-hand side? Good. Then she better do 2 over X. Okay? Unique. Didn't see anybody else do it that way, but that works. All right, Myrna. How'd you set yours up, Myrna?
I did 10 divided by 18 equals y over 3.
Do your X.
Oh.
Give me the one you set up for X.
X over 2 equals 10 over 3.
Good. So Myrna sees it as I would probably do it. So if I were to do this and wasn't kind of showing that there's a lot of different options here, this just makes sense to me that if I want 2 fractions, here's my top, here's my bottom, and then here's my top, here's my bottom. So that's typically how I set them up when I do them together. All right. So Heilman did a little bit differently than me. Myrna did it like I would have done it. Hannah T, how did you set yours up?
I did x over 10 equals 2 over 3.
So she did left-hand side compared to the right-hand side. So as long as she does left-hand side here compared to the right-hand side there, 2 over 3, those would also work. All of those are correct. Every single one of them, if I cross multiply, will give me 3x equals 20. Right? So here, 3x equals 20. Here is a 3x. Cross multiply equals 20. As long as you put the things in the correct spot and they match up left to right-hand side, all those are going to give you the exact same answer. Okay? So hopefully, you could have a different one even. There's still another 1 or 2 out there that you could have set up. Marian had a different one, okay, to get his X. So there's a lot of different ways that we can do that. Either way, though, you should get that 6.6. All right. Although I do know Marian got Y. Give me your Y setup, Marian. Good. So he did, and again, this is probably different than what a lot of people did. He did the big over the small. So what he started with was the big right-hand side. So the right-hand side of the big triangle is 13. The right-hand side of this small triangle would have been that 10. And then now when he goes to do the bottoms, he, again, has to put the big bottom on top. So the 18 has to go on top. And then the small bottom, which is the Y we're looking for, needs to be the bottom. Okay? Now, I'm willing to bet very few people have that, and that's okay. The key is when we crisscross and solve this. So when I get 13y is equal to 180. I don't know what that is. What's that give us? Whoa, what was that? 13 point what? That's not sounding familiar to me. Everybody get that? 13.84.
Well, it's like a low number. Yeah, it's
Did we not? I don't remember that. I don't.
But they must have just rounded it to 13.8.
Maybe.
So I remember it being 13.8.
Okay. All right. Then we're good. All right. And again, you probably didn't do it that way. Okay. That's a little different. I would have probably just done y over 18, the small bottom compared to the big bottom, and then do the small right-hand side over that big right-hand side. But it's ultimately the same exact thing, just a little different rearrangement. Okay. Okay. We'll finish with one more. Do letter C. See what we get. And then we'll call her a day, probably. Do C. Pressure.
not the first one.
You're serving down 24-25. Quality second championship game. Like, can't hit that thing out of bounds. Yeah, good.
Mine's a good question.
Sure. Line up like a teacher.
So this would be 6. It's kind of
It is the same as this. It's just
Okay.
rotating a little bit. So, like, this is your parallel side.
yeah.
So that is the side that's splitting these two sides. So, so this is your parallel side that's splitting these two. So that's why you can do x over 2. So this guy's now kind of upside down if you approach it like this. So it's really 6s and 9s opposite. But it would be this guy over this guy equals this guy over this guy. Now we don't have that. So like a variable. But that's your section. This over this equals that over that. So if you're going to do 9 over 6, where are you trying to find this out? So if you're going to find this guy, you're going to do the small left side, big left side, 6 over. That means
No, but not yet. Okay, I got it wrong. No, I got it.
the big side is 2, 9 compared to 15. And 6
What?
here.
She said I did. You're smarter than me.
All right. Most people are doing this one the same way. So let's see where we're at here before we go. Riley, what'd you set up?
I did 6 over 9 equals x over 1.
Good. So she did this over. So this is our parallel side that's splitting these two sides. So we can just do 6 over the 9. She didn't know what this side was, so she assigned that an x. And then we do the x over the 1. All right. I saw a lot of 9 over 6s equals 1 over x. That's also fine. Okay. That's the same exact thing. So that when we crisscross this, you're going to get 6 is equal to 9x. You won't like this number again, but that's okay. That is your answer, 0.6 repeating. And then the y, again, walking around. This is the one that some people are missing. And that's typically how this works. This is, I'm going to call this y since this is the side that I'm looking for. So I am going to do that Y that I'm looking for. That's the left-hand side of the big triangle. So the left-hand side of this big guy. This is the left-hand side of the small one. So I'm going big over small. So now the sides that I know are the right-hand sides here. What is this big right-hand side length? What is that total length going to be? 15. Then if I go to the smaller triangle, what is its right-hand side going to be? The 9. So that should have been your setup, or at least something comparable, so that when we crisscross and solve this, I get 9y equals 90. So whatever your setup was, as long as you got that y to equal a 10, then it would have been equivalent to the one that I had set up. Okay. Okay, bring us tomorrow. We'll jump into this new little section here, and then you're spared for tonight. What's that? Yeah. Big one. No homework. No. Mañana. Probably there with some stuff there. I don't have any legit passes. Plus, we're not really supposed. I honestly don't have. I've been writing passes on this to kids. There's no way librarians are going to take that. They're very strict about it. I'd rather not, Hannah. I honestly don't have any passes. I don't even know where to get them. Plus, you don't need pass.
Somebody else.
Yeah. It's someone else.
Hey guys.
Making stuff up.
Bye.
Stuff up second.
There it is.
Oh, where was it?
It was underneath. It was in the stack of homework.
Oh, okay. Yeah, 26 paper.
Yeah, oh, Henry's is in there too.
It's another reason I, at least considering not coaching anymore, just the nonstop, never being able to just relax very long.
I'll have to remember that that's sitting right on top.
Yeah.
When he asks again.
No, I don't. And I recorded this, right?
Yeah.
But I still have yesterday's up.
Jackson.
I don't know if it worked
Oh,
because I never uploaded yesterday's apparently. Shit.
Riley said she was watching it.
Yeah, you're right. Did she subscribe to me then? I uploaded it, but I didn't put it on Canvas. So I guess you could see it on YouTube. But
She must just have the.
oh, there it is. There it is. Here